Alrighty. All right, so look at the Glacier seafood web, the same food web that we've been using for the unit, and think about the question. So besides the sea turtles and the zooplankton, what other populations might affect the size of the jellies? So take a look at that food web. And other than, we've already talked about the zooplankton, we've already talked about the sea turtles, which other population or populations could affect the moon jellies? Think about what you did in the sim.
The walleye.
Good. How come the walleye could affect the moon jellies?
Because if there's more walleye, they're eating more zooplankton, and if there's less zooplankton, the moon jelly.
And then the moon jellies would do what?
Then they would reproduce less.
So they'd go down. So let's reverse that. What would be happening to go on with the walleye in order to increase our moon jellies?
If the walleyes decrease, then there'd be more zooplankton for the moon jellies to eat.
Right, which would give the moon jellies more energy storage molecules to reproduce. So this would be similar to, even though it looks a little different, the furbills, the wee bugs, and the stingwings, right? If we want the stingwings to increase, then our walleye population, or our furbill population had to go down. So the walleye could affect the moon jellies. Is there anything else that you think could affect the moon jellies on there? All right, we'll come back to that idea then. So in the last lesson, we discussed how populations can compete with each other. The walleye pollock compete with the jellies for the zooplankton. The orca and the jellies don't compete, the orca and the algae, they don't compete with the jellies, but they are indirectly connected, right? We talked about those indirect effects. So they are indirectly connected. That means that we can trace a line from the algae to the moon jellies, or from the orca to the moon jellies. However, the sea urchins and the kelp, on the other hand, they're not connected to the moon jellies at all. Okay? They're not indirectly connected. There's no way to get to the moon jellies from the kelp or the sea urchins. Populations can affect one another in many ways. For example, some populations compete for space or even oxygen. But in this class, in this unit, we're only focusing on the way populations can affect one another that have to do with eating relationships, like what we can see on a food web. So next, you're going to conduct 2 missions to investigate other types of indirect effects that are not competition. For these missions, you're going to use the 6 populations mode again. That's the last one that has the cat claw and the scale beaks. And you're going to try to change the population size without changing its resource or consumer population. In mission 1, you're going to try to increase the claw cat without changing its resource population, the scale beaks. In mission 2, we'll see if you can decrease the size of the greenleaf population without changing the size of its consumer population, which are the wee bugs. So let's go to Google Classroom and open up number 2 for today. We're going to make a plan to use indirect effects to complete 2 missions in the sim, then carry out the missions, and then you'll come back here when we finish. So when you open the number 2, this is what you should be looking at. Oh, I have that big space. It's weird. So populations that are not directly connected on a food web can still affect one another. These are called indirect effects. Plan how you will complete 2 missions in the sim that involve indirect effects by answering the questions below. The food web from the sim is below for reference. So there's the food web that we use in the sim. Your first mission is to find a way to increase the size of the clawcats without changing the size of the scale beaks. So here's our clawcats. We're not allowed to touch the scale beaks. So which population do you think we need to probably change then? Well, let's back up. If we want to increase the clawcats, what do they need?
More energy.
They need more energy. They need more food. Where do they get their food from?
Furbills.
They do? The clawcats?
Scale beaks.
Right, they get it from scale beaks, right? So clawcats get it from scale beaks. So they're going to need more scale beaks to reproduce more. So then you want to back up one more step. How can we get more scale beaks? What would have to happen to furbills?
Increase.
To get more? What did you say?
You would want to increase the furbills.
Would that give you more scale beaks? Olivia? Decrease, right? Because if you increase your furbills, they're going to eat more scale beaks.
Scale beaks ate the furbills.
Oh, you're right. Let me back up. I am so sorry. I'm looking at my arrows wrong. I'm going backwards. I am sorry. Yes, Nathan, you were right. You want to increase your furbills so that the scale beaks have more to eat. Sorry, Olivia, I drove you down the wrong path there. You want to have more furbills so the scale beaks have more to eat, so they reproduce more, so you have more clawcats. Okay? So we're going to scroll down. And you want to highlight your choices. So we said increasing, furbills. And then the second mission is to find a way to decrease the size of the green leaves without changing the wee bugs. So if we look back here, we want less green leaves, but we can't touch wee bugs. So what other options do we have?
Decrease furbills.
What would decreasing furbills do?
It would increase the wee bugs because less of them would get eaten.
Right. So if you have more wee bugs, then they will eat more green leaves. Good. Is that the only thing we could do?
No, you could also increase the or decrease the stingwings.
Right. Decrease the stingwings. That would give more wee bugs, right? So either one of those, we predict, would change our green leaves the way we would like. So go ahead and make your choices, whichever one you want to do. Either way, we do need to decrease. And then you can choose which population you want to do, stingwings or furbills. And now you're going to complete the 2 missions. So mission 1, remember, find a way to increase the size of the clawcats without changing the scale beaks. So go ahead and click your sim. Mine is not working. Is yours working? Is your link working for the sim? Right. Mine. This is weird. I don't know what's going on with it. There we go. Okay, now we've used this sim many times, so I want you to work through the directions. I'm going to come around and help, but I do want you to work through the directions on your own. You're doing many of the same things that we've done before. The first thing is the 6 populations, and then the food web overlay, which I'll show you. This time you're running for 20, making your change, running for another 300. Okay, so those are your times that you're letting it run for. My computer is not happy it's me. Okay, so when you're on the sim, because apparently mine's not opening at this moment, you want the food overlay, food web, if you even need it. Maybe it's my mouse. Is in the bottom left-hand corner. It looks like a share button if you need the food overlay, web overlay. So go ahead and work on those 2 missions, answer your questions. I will be around to help you. Okay. So you should have the document that you just answered the 2 questions on. Mine's still not cooperating. So we're going to quickly here think about the submissions that you should have completed. So how was the clawcat population increased without changing its resource population, and why did this work? Is there anybody who would like to share what they wrote for that first question? Please. I beg of you. Thank you, Nathan.
If you increase the furbill population, there's more energy storage molecules for the scale beaks, so they can reproduce more. So then there's more energy storage molecules for the clawcats, so they can reproduce more.
Very good. So increasing the furbills and increasing the wee bugs, you could have done either one, does cause the clawcats to increase. Clawcats eat scale beaks eat furbills eat wee bugs. When the wee bugs increase, the furbills have more energy storage molecules and more births, leading to an increase in the furbill population. When the furbills increase, the scale beaks have more energy storage molecules and more births, leading to an increase in the scale beak population. When the scale beaks increase, the clawcats have more energy storage molecules. This leads to more births and an increase in the clawcats. So your answer should start somewhere here when the furbills increase, right? We didn't do the wee bugs, but we could have done the wee bugs.
Good morning, Acton Middle School. Students, if you did not get breakfast and you wanted breakfast, after the bell rings, in the middle school cafeteria, there are bagged breakfasts. If you need a few minutes to eat, you can stay in there and eat for a few minutes. Typically, we don't like to do that, but everybody needs the opportunity to have breakfast if you want the breakfast, okay? So again, if you want breakfast this morning, you can go to the middle school cafeteria after the bell rings and grab a bag breakfast. Thank you, have a good day.
So the clawcats are closer to the furbills than the wee bugs on the food web. So that's why I talked about increasing the furbill population instead, to make that change happen quicker and larger. So while increasing the wee bug population will lead to a smaller increase in the clawcats. The closer the population is on the food web, the larger the change, right? The more direct of an effect it would have. So then the greenleaf population, we wanted to decrease without changing its consumer. So we decreased the furbills, causing the greenleaves to decrease. This is what you should have for your second answer. Furbills eat wee bugs and wee bugs eat greenleaves. When the furbill population decreases, they eat fewer wee bugs. This leads to fewer wee bug deaths and the population increases. A larger wee bug population will eat more green leaves, leading to more deaths, and the population will decrease. So both of the, anyone need that? I'm sorry, I told you that's what your answer should be. I didn't leave it up there for you. We're all good? Okay.
I just did the
Were you
sting
good?
wings.
Sorry. My back's to you.
I just did the sting wings instead of furbills.
Okay, yeah, that's fine. So your submission provides evidence for this key concept. The size of a population can be affected by any population that it is connected to in a food web, even if they are not directly connected. So we talked about that competition example, but now you have the ends of that food web that can affect the jellies even though it's not directly connected to them. So we are done with lesson 10.1. Tomorrow you will do 10.2, which is kind of putting your thoughts into what you think is going on in the jelly ecosystem. And then we will eventually make our final arguments. Make sure that you turned in today's Google Doc so that you do get credit for that.